In this video, we will see how to program a sanding application using a UR10E robot from Universal Robots and the Hex-Force torque sensor and sander from OnRobot. As the desired surface finish of this workpiece is obtained by sanding it with 5 grits of different roughness, we will use the OnRobot's grit changer for the robot to automatically switch between the different grits without any operator intervention. Keep in mind that the vacuum hose must be fully secured to the sander, and the robot should be able to move freely without having the hose pulling on the arm, as this could negatively affect the surface finish. A relay will be used so that the robot can turn on and off the vacuum or dust collection system. A simplified diagram of this connection is shown. The robot will be programmed to sand the following 3 surfaces of the wooden table, while moving the sander parallel to the wood grain. The OnRobot products include a USB drive where we can find the user manuals and the necessary software to easily control the devices from the UR graphical user interface. Keep in mind that OnRobot is constantly improving and updating its manuals and software, so the latest versions can also be found on the website. After mounting and connecting all the required hardware, it is time to start programming the robot. Connect the USB drive to any USB port available on the robot and install the UR cap stored inside the USB memory drive. Restart the robot to complete the installation. After installing the UR cap, it is time to configure it. In the drop-down menu, we need to select whether the devices are connected to the tool connector of the robot arm or, as in this case, to the Ethernet port of the controller. OnRobot has developed a unified UR cap that can control all the devices. It is not necessary to download different UR caps for each tool. To avoid installing all the functions for all the devices on the robot, the UR cap will only install and enable the appropriate commands from the detected devices. After restarting the robot, let's double-check that everything is correctly detected. To maintain the Ethernet selection on the UR cap, we need to save the installation file. Now we can continue to set up the installation of this robot. Before powering on the arm, it is important to define the correct payload and center of gravity parameters. We can easily find these values in the user manual. Now, let's power on the arm. Let's go ahead and define the correct tool center point, also called TCP. As shown, the robot is using the default one defined at the 0 position. In the drop-down menu, we can select the correct TCP provided by the UR cap. Don't forget to select it as the default, otherwise the robot will continue using the previously defined TCP at the 0 position. To make programming easier, let's also change the name of the digital output signal that the robot will use to turn the vacuum system on and off. We will also select the action to automatically turn off the vacuum signal in case the program or robot stops. Finally, let's save the installation so that we don't lose any of these configurations. Now we are ready to start building our sanding program. Let's start by disabling the Program Loops Forever feature, since we want this program to stop after sanding the workpiece with the final grit. We will also add the Before Start sequence, where we will place some comments to easily see the purpose of this program. The Before Start section is the ideal place to define variables, devices, and signals. So here, we will initialize the vacuum's digital output to low. At the beginning of the program, we will define the starting position of the robot. To increase the readability of the program, let's change the name of the waypoint to Home. There are many options of moving the UR robot, but we will take advantage of the hand guide feature of the HEX sensor, as this makes it really easy to move the arm. After placing the robot at the desired home position, let's ensure it is perfectly aligned to its base by pressing the Snap to Axes button. Now we can disable the hand guide feature and save the waypoint. As we want to sand the wooden table with 5 different grits, let's add a loop instruction to repeat the sanding operation 5 times. Inside the loop instruction, we will add the OnRobot's Sander Surface Finishing command. This command makes it very easy to program the robot to perform a sanding operation. We only need to define a couple of parameters, the trajectory that the robot must follow, and it will take care of everything else. Let's start configuring the material presets of this command. Here, we need to define the relationship between the force that the robot needs to apply to the surface, the rotation speed of the sander, and the speed of the robot's TCP while following the sanding path. These values will depend on the material of the workpiece, the surface condition, and on the sandpaper grit. For the wooden table, we will keep everything with the default values except for the force and the speed of the robot's TCP. We will save our material preset and give it a better name. This is also a good place to save our robot program and installation files. Now let's define the position from where the robot will approach the surface. This point should be placed a short distance from the surface and also be aligned to the first point of the sanding path that we will define later. Below the approach point, let's add the instruction to turn on the vacuum. In the sander RPM instruction, we can define the rotation speed of the sander and choose if we want to turn it on when the robot is at the approach position, or if we want to search for the part and turn it on after the robot comes into contact with the object. We will keep this feature for our process. The sander control instruction controls the force and torque that the robot will apply to the surface as it follows the sanding path. Since, for the wooden table, we want to always keep the sanding disc flat against the surface, we will only apply a force of 15 newtons and keep the torque value at 0. The force control section allows us to define how precisely the sander will follow the surface. The higher the percentage value, the greater the surface tracking ability, but that could also introduce vibrations on the arm. The purpose of this is to compensate for some small differences between the workpieces where the robot needs to adapt to the contour of the surface while sanding. The best results are obtained when the sanding path is precisely defined and all the points are perpendicular to the surface. A 25% keep force value should be suitable for most applications that have a well-defined sanding path. Before adjusting the force or torque control parameters, check the sanding path and always test the performance after making any small adjustment. The force control feature is a very powerful tool that enables delivering a high-quality finish, but for it to work as expected, it is important to precisely define the sanding trajectory. To provide maximum flexibility, there are a couple of different options for creating a sanding trajectory. We can record a path while hand-guiding the robot. We can define many independent points to tell the robot how to move from one to the other. We can easily create shapes with very few corner points, or we can create a complex trajectory by combining all these options. For our workpiece, we will use the Path from Shape option to define the trajectory for the flat and curved surfaces. Let's start with the top horizontal surface. Here, we only need to define the 4 corner points of the surface, the path direction, if we want a sharp or curved edge, and how much the pad should overlap. For our workpiece, let's change the edges to curved and reduce the overlap to about half of the pad. After defining the 4 corner points, the command will automatically create the path for us. Now for the curved surface, we will follow a similar approach as before. We can easily define a curvature by adding another column. Remember to define the points perpendicular to the surface. Let's complete the sanding trajectory by adding the path for vertical surface. The final sander RPM instruction allows us to control how and when to turn off the sander. By default, it will retract 5 mm from the surface and then stop the rotation. After retracting the sander, let's add an instruction to turn off the vacuum. Now that we have finished defining our surface finishing command, it is time to move the robot to the grit changer. Let's add a couple of transit waypoints to ensure the robot can safely approach the grit changer. The grit changer instruction automatically handles everything necessary for the robot to change the sanding discs. We just have to select the orientation according to the layout of the application and define the pick position. To define the pick position, remove all sanding discs from the changer and place the sander perfectly flat on the base of the grit changer. Since the command will calculate all other points based on this pick position, it is important to set it correctly. We can also add an error handling sequence in case there are no more grits or the robot cannot change the grit successfully. Let's watch how the robot automatically changes the sanding grits. Now we will program a couple of waypoints to safely move the robot back to home to sand the workpiece with the new finer grit. After sanding the part for the last time, the robot will move to the home position and the program will stop. We are finished with our sanding program. Let's speed up the simulation and watch the start of the application.